Students, आज हम लोग सीखेंगे कुछ स्टैंडर्ड फॉर्म ऑफ रियल फंक्शन स्टैंडर्ड फॉर्म ऑफ रियल फंक्शन एंड their graph. If you have not subscribed this channel, then subscribe. I must appeal to all of you to subscribe this channel to get subscriber videos and to get other videos also. If you subscribe, then you get all these videos uploaded by me. So must subscribe. And if you like, then like, comment me, and if you like, then share it with your friends. So let's watch. Start and watch. First function we know. What is constant function? Constant function is that first if we I want to share with you what is a function. Function is a if you take a Cartesian plan, x and y axis uh, meet perpendicularly, then let's say Cartesian plan. Here x is a independent driver and y is a dependent driver. Then I will get a function like that y equal to f. And if we put all these values of x, then we will get a function or a graph of y. So this is y equal to fx. This is y equal to fx. So if we now take what is constant function. Constant function is that if we keep the value of y constant, a certain number, any number certain for all the values of x. We are taking k. This is fixed, but for x varies from minus infinity to infinity. X varies from minus infinity to infinity for all values of x, but y will be kept at constant. Y will keep at constant a certain value. Then this function is called constant function. Its graph will be in this way. This is the y-axis and this is the x-axis. So here x-axis, y-axis. If we take any point on the y-axis 0k, then for all the values of x, it must pass the point k. The line must pass the point k only. Why take just certain value, just k, at all the points on x axis. So it must be a straight line, the constant function, and must be parallel to x axis. Here you can look this straight line y equal to constant is parallel to x axis. This is called constant function. Now let's move another function. This is called identity function. Identity function. Here as a function y equal to fx will be same as that of x, means y is equal to x. This function is equal to x. What will be the value of x? The same value will be the y. So very easy is graph to look of identity function. Let's again y axis, and this is x axis. So what will be the value of x? Same value will be y. If x is 1, then y will be 1. X is 3, then y will be 3. X is minus 1, then y is minus 1. X is minus 4, then y is minus 4. So the graph will be in this way. Contains all the points where x and y are equal. Here y is equal to x. This is the identity function. Now let's another function. This is called modulus function. Modulus function. The function is there such equation is in this way. Y is equal to mod of x, means y always be positive. Always will be positive greater than equal to 0 for all values of x. In another way, it can be written in this way: y is equal to plus x if x greater than equal to 0. If x greater than equal to 0, and when x is negative, then it is equal to minus x. When x is negative, then it is minus x. Means y must be positive. Y cannot be negative. So graph will be, again we are taking y axis, and this is x axis. So x and y. Now if we take the point 2, then y will be positive 1, 0, then y is 0. If we take 4, then y is equal to 4. When we will take minus 2, then y will be plus 2. Y cannot be negative. When we will take minus 5, y will be plus 5. So in this way, the graph will be. So this is the graph of modulus function y equal to mod of x. Now let's move another function. This is signum function. Signum function. Signum function is defined in this way: y is equal to f(x) equal to it will be equal to mod of x by x for x not equal to 0, when x not equal to 0, and 1 and 0 for x equal to 0. It is a discontinuous function. It is not continuous function. So it can be briefly can be further written in this way: we break this modulus, then it is equal to when x is equal to greater than equal to 0, it will be 1 when x greater than equal to 0. When x greater than equal to 0, it will be positive 1 plus 1. When x less than 0, it will be minus 1. X less than 0. And when x equal to when 0, then it will be 0. So when x greater than 0, it will be 1. When x less than 0, it will be minus 1. And when x is equal to 0, it will be 0. But it is a discontinuous function. How its graph is? So its graph will be, this is the y-axis and this is the x-axis. Y. So y will be 1 where x is greater than 1 and 0 when 0. So here will be a point 0 0 point, and for greater than 1 it will be 1, just y will be 1 for all the values greater than 0. So it does not touch the y-axis. This straight line pass through just in the neighborhood of the y-axis, and another line just passes through the y equal to minus 1 but don't touch the y-axis. So there is a break. It is a discontinuous function. Its graph is in this way. So this is y equal to 1 positive, y equal to 1 but it cannot be written. So in this way this graph can be represented signum function, discontinuous function. Let's see another function. This is the exponential function. It is we equal to, actually it is written in this way, it will be of any integer not equal to 0, any integer or any number, real number not equal to 0 to the power x. So now the case can be that a cannot be negative, a always be greater than 0. So here can be two cases. One case is that if a lies between 0 to 1, a lies between 0 to 1, then what will be y? Y will be x is equal to, it will be less than 1 while for all x less than 0, and equal to 1 for x equal to 0, greater than 1 for x greater than 1. Now this is the first case. I am drawing first its diagram. Sorry, this is the case for, and I have to explain this. Uh, this is case for a greater than 1, not for 0 to 0 to 1. So this will be for a greater than 1. Second case I am discussing. Just wait. I am first draw this diagram. So here A is greater than 1. This diagram will be this is x-axis, this is y-axis, the origin. Now it will be when A greater than 1, the graph will touch the point 0, 1. The graph will touch at point 0, 1. This is the point 0, 1. Now it passes through in this way. Now it does not touch the x-axis. Passes through in this way. So this is for A greater than 1, y is equal to A for all value of x. And also you can look this, that what is the graph of 2 to the power x, 3 to the power x. This is the graph x to the power 2 to the power x. The x, all the parts goes through 0, 1 point. All the 2 to the power x to 3 to the power x, 4 to the power x, all goes from the 0 to 1. So 2 to the power x will be in this way. This is 2 to the power x. 3 to the power x will be in this way. 3 to the power x, and 4 to the power x is in this way. This is the 4 to the power x. So in this way, if A is greater than 1, these graphs are found. So now let's discuss the second case where A varies from 0 to 1. Then the y is equal to Ax is equal to greater than 1 for x less than 0. X less than 0 is equal to 1 for x is equal to 0. And less than 1 for x greater than 0. So its graph will be in this way. Y-axis. So here also the graph passes point 0, 1. Graph will be here A varies from 0 to 1. A varies from 0 to 1. The graph will be the reverse of the case point it greater than 1. So it does not touch the x-axis and goes through in this way. This is y equal to ax. So A ranges 0 to 1. And some examples are also equal to some examples. This is x-axis, this is y-axis, this is the origin. So all the curves must pass through 0, 1 point. And here we will take first half of x, range is from 0 to 1. So half of x will be in this way. Half of x will be in this way. This is half of x. So 1/3 of x will be 1/3 of x will be in this way. This is 1/3 of x. And 1/4 of x will be in this way. In this way. 1/4 of x will be. So these are the examples of y to the exponential functions when a ranges from 0 to 1. So let's move now one more function which is logarithmic function and logarithmic function. Logarithmic function we know what is logarithmic function. It is written in this way: y is equal to log of x, and x always greater than 0, where x always greater than 0. So here we are taking the basic a. We basic a, then so the changes of a defines it, and here of course x greater than 0 because logarithmic function is non-negative and not non-zero also. So non non-zero means it is not defined at the point 0 and for negative values. So here are some cases. Case one is that where the logarithmic function where a is greater than 1, this base a is greater than 1, then what will be a greater than 1. Then the function can be defined in this way: y is log of x base a is equal to its value will be less than 0 for x where x having values between range 0 to 1, equal to 0 when x equal to 1, when x is equal to 1, and greater than 0 for x greater than 1. So we first draw this diagram of case 1. Here diagram, this is y-axis and this is x-axis. X, this is y-axis, this is the origin. So we are discussing about why a is greater than 1, the base is greater than 1. So the diagram is found that the diagram is found that in this way it must pass through 1 0 point. Like exponential function always found that passes through 0 1, and logarithmic function always passes through 1 0 point, and it is always uh, it cannot be it is not defined for x equal to 0 and for uh, negative values of x. So, for x 1 it will be graph in this way. It will come closer to x-axis and just pass through the y-axis, but don't touch the y-axis. This is y is equal to log of x base a, where base a is greater than 1. So this is the graph of the logarithmic function. Case 2, it can be that the base is ranges from 0 to 1. Case 2 is that the base is ranges from 0 to 1. Then function logarithm of log of a base a is defined in this way. It will be greater than 0 for x ranges from 0 to 1 and equal to 0 for x equal to 1 and less than 0 for x greater than 1. So its diagram will be just reverse of the case of base a greater than 1. Look this. This is x-axis, this is y-axis, this is origin, and of course it passed through from the point to the point 1 0. It will be the opposite of the case of e to the power greater than 1. This is the case from a ranges 0 to 1. The base ranges from 0 to 1. The graph found closer to y-axis, and then it passes through 1 0 point, and also just keep away from the y-axis in this way. This is y is equal to log of x base. So these are the functions. I hope you like this video. If you like, then like, share with your friends, and subscribe this channel. I will also load more topics on the variables. To get this video, must subscribe this channel. Keep watching this channel. Thanks for watching.